We're going to go ahead and get started here on our next unit. Our next unit is going to be exponents and radicals, and to begin with we're going to look at the properties of exponents. And we need to make sure we understand some basic vocabulary here to begin with. I'm going to be using this terminology throughout this section, so we need to make sure we understand what a base is and what a power or an exponent are. When you look at the picture here, we see that we have a base of 8. That means that's our large number at the bottom. That's what we're raising to a power. The exponent is the smaller number that is raised up on top there. And I'm going to assume we all know what an exponent does to a number. We're not going to spend time reviewing that. We're going to go ahead and jump right into our rules here for working with variables and exponents. And our first rule is going to be our product rule. Our product rule says when two values of the same base are multiplied, the exponents are added. So we're going to do some basic calculation here where we're looking at a situation such as this: x squared times x to the fourth. You recognize the bases are the same. Both values are based in x. And so we have x to the second, x to the fourth. And if we remember what our exponents mean, you see in parentheses there, we've written out x times x and x times x times x times x, because that by definition is what x to the second and x to the fourth are. So when you look at that, that's really just one long string of multiplications. So therefore we can put those all together into one multiplication, which leaves us with 6 x's all multiplied together, which is x to the sixth. So this is kind of the justification for our product rule, so we can see why it works. So this brings us to our rule then that just says now we're not going to write all this out anymore. We're just going to say if we have x to the second times x to the fourth, we're going to realize we can add our exponents together, getting us to x to the sixth. So let's look at an example here that has multiple variables and some constants in it. When you see our example here, we have 3x to the third y times 2x to the fourth y to the third. When we multiply these, it's much like our concept of combining like terms. We only look at numbers with numbers, x's with x's, and y's with y's. So when we multiply the 3 by the 2, we end up with 6. Now you notice we do not change our rules for multiplying numbers. Those rules you've known since 4th grade will never ever change. Our rule only applies to multiplying exponents. So you do not add the 3 and the 2. You multiply 3 by 2 to get 6. Then we multiply x to the third times x to the fourth. Here comes our product rule where we do 3 plus 4 is 7. And in order to do y times y to the third, we need to make sure we recognize on this y, if there's no exponent there currently, there is a 1 in here that we can assume there's one y there. So therefore y to the first times y to the third is y to the fourth. So that's your product rule. Our second rule is going to be our quotient rule, and it should make sense. If the product rule requires you to add your exponents, the quotient rule would go the other way. It would require you to subtract your exponents. So the actual written out version says when two values of the same base are divided, the exponents are subtracted. So when we look at our example here, we have x to the sixth divided by x to the second, and we wrote out 6x's and 2x's. Now, division is the same as fractions, and so when we're dividing with exponents, what we're really doing is reducing a fraction. I see I have an x on both top and bottom, so I can divide that out of the top and bottom. I have another x that can be divided out of both the top and bottom, leaving me with 1 on the bottom and x to the fourth on top, and so x to the fourth over 1 is x to the fourth. So that's our proof of this rule. That's our showing that this rule does work. You can divide by subtracting the exponents. Our quotient rule does bring in some interesting situations here that we need to address. And our first special case we need to look at is when there's a larger exponent on the bottom. So based on our quotient rule, this top part here must be true. X to the second divided by x to the seventh must equal x to the negative fifth. That has to be true. That's our quotient rule, so therefore that must be equal. But when we write it out, if you look here, I have x times x over x times x, and we have the 7x's on bottom. And if I do that same rule where I say I can divide an x out of the top and bottom, and I can divide another x out of the top and bottom, my simplifying fractions rule tells me this. If I divide everything out of the top, I'm left with 1 on top And on bottom, I still have 5x's down there, so that's 1 over x to the 5th. So if both this top rule and this bottom rule are true, which we know them to be based on our math rules, then this statement must also be true. 1 over x to the 5th must be the same as x to the negative 5th power, because we've just shown we've done two separate problems we've done the same problem twice and in two different ways and gotten these two different answers. So therefore these two must be equal. And they are, and that brings us to our rule on negative exponents. A negative exponent can be changed into a positive by changing sides of the fraction. When we look at our example from above here, we had x to the negative 5th, and we said that's the same as 1 over x to the 5th. So that x to the negative 5th is on top right now. It moves to the bottom to become positive. So if we look at this other example here of 2 to the negative 3rd power, this is something you can actually do in your calculator. Is you can type in 2 to the negative 3rd, and you'll notice your answer is not a negative value, because that negative exponent simply tells you to take your 2 and move it to the bottom of the fraction. So it becomes 1 over 2 to the 3rd power, and 2 to the 3rd power is 8, so that becomes 1/8. And if we look at an example with variables in it, this x to the 4th divided by x to the negative 3rd. Now you notice we put the negative on the bottom. What that negative exponent tells us to do is switch sides of the fraction. So that negative 3 moves itself up to the top and becomes positive. So we actually have x to the 4th times x to the 3rd over 1, which we don't really need the over 1 when we get to our answer. So our answer is simply x to the 7th, because we now have the product rule. The second interesting thing that's brought up by the quotient rule is the idea of 0 as an exponent. And so if I would ask you this question, what is 234 to the 0 power? When you look at that, that seems like it's an odd question, and I'll usually get different answers, like 234 or 0 are my two common answers there. But when we look at our two problems below here, we have x to the 3rd divided by x to the 3rd, and based on our rules that we've done here with our quotient rule, that has to be equal to x to the 0, because 3 minus 3 is 0. But also, we have a rule from back in 4th grade that's causing us another problem here. Because when I look at it this way, I have to say x to the 3rd divided by x to the 3rd. Well, something divided by itself is 1. We learned that back in 4th grade, where we saw 10 divided by 10 is 1, 50 divided by 50 is 1. Anything divided by itself is 1. So again, much like our negative exponent situation, we have two math rules kind of running into each other here that are causing us to make an observation. That observation is that if both of these statements are true, then x to the 0 and 1 must be equal. So that is our rule for 0 as an exponent, is if you get anything to the 0 power, it is equal to 1. So even 234 to the 0 power is equal to 1. And the reason why that is, we showed down here. So let's look at an example where we put the product and quotient rule together. Now it's important we understand here, everything we're doing is multiplying and dividing. Now our rules might tell us to add or subtract, but because everything we're doing is multiplying and dividing, there is no order of operations right now. The order you do these in doesn't matter, and if you did them in a different order, you could come up with the correct answer. Also, it's important to understand our answers will never be able to contain negative exponents. Similarly, the way that we simplify fractions all the time, we never leave a negative exponent in an answer. So let's look at this example. X squared y to the 5th times 6x y to the negative 4th over 4x to the negative 4th y to the 2nd. So there's a lot going on here. My advice to you when you get into these more complex problems is do them in their parts. Don't get overwhelmed by trying to look at the whole thing. So to start with, we're just going to simplify the top. X squared y to the 5th times 6x y to the negative 4th. When I simplify that, my 6, I move the number in front, and then I simplify my x's. I have x squared And again, I have that assumed 1 in here. And so I have x squared times x is x to the third. Y to the fifth times y to the negative fourth would be y to the first. And again, you notice I didn't write that. And then on bottom, I have 4x to the negative fourth y to the second. I didn't change anything because there's nothing that can be simplified on bottom. For my next step here, I'm going to get rid of my negative exponents. The negative exponents aren't allowed in my answer, so I'm going to rewrite my problem with this x to the negative fourth here. I'm going to move that to the top, and you'll see it down here where it simply moved to the top and became positive because that's our rule for negative exponents. Everything else stayed the same. 6x to the third y is still on top, 4y squared is still on bottom because those had positive exponents. So our next step, I put together my x's on top. I have 6x to the third times x to the fourth is 6x to the seventh times y. On bottom, I still have 4y squared. Now to get to my final answer, I'm going to do my quotient rule. But first, I have to look at this 6 over 4. 6/4 reduces to 3/2. That's still just a fraction. They're just numbers. We don't use exponent rules on numbers. So I'm left with 3 over 2. My x's don't have anything to go with, so it stays x to the seventh. And my y's, I have y on top and y to the second on bottom, so therefore I have one more y on bottom than I do on top, so I'm left with y to the first. If we wanted to, we could write that out as this y to the first. 1 minus 2 is negative 1, and that negative 1 forces it to move to the bottom. But it's easier to simply think about the quotient rule in this way. Where are there more y's? In this case, there are more y's on bottom, so my answer will have y's on the bottom of the fraction. Alright, I know this video got a little bit long, and I apologize for that, but there's a lot of information here that we need to get across. So tomorrow we'll add another rule, and we will finish up with some more complex examples, and we'll be ready to go tomorrow. Thank you. Bye.